So think back. We have a mass L naught, right? We have an object L naught length. We sort of force on it, and we cause it to bend downwards, and it bends down some distance delta L. So we know that stress is equal to modulus times strain. Okay, this is shear modulus. Your book uses G. Now, let's do some algebra here. F equals GA over L naught delta L. Okay, and so that is going to be the force here that it takes, and then delta L is how far it moves. Now notice G, the shear modulus, is dependent on the material. That's constant. A is constant. L naught is constant. So all the stuff in parentheses is constant. Well, if you think about a spring, okay, exerting force on the spring, and now the spring stretches some distance x. Okay, and so what's happening is each little segment of the spring is stretching some equal amount delta L. Okay, and so there's n of those, and so the total x is going to be equal to n delta L. Well, if each one of these, you call that L naught, and each one goes some delta L, then the F equals the G times the A over L naught in delta L. Okay, and so F equals G A N over L naught delta L. Okay, well, that's x. So what's happening is that we can also think about this as just being x right here. Okay, and so now this right here is going to be a constant. So we can just call that constant k. Okay, well, notice what we've derived here. F equals kx. That's the force we're pulling here. There's an equal and opposite force minus right here. So that's going to be minus kx. So what that means is that if a spring is stretched some distance x, it's going to pull back with a force kx. If you squeeze a spring, then it's going to push back with a force of minus kx, because in this case, x is going to be negative. And so what we've got here is F equals minus kx. That is Hooke's law, named after Robert Hooke, which we just stated without proof earlier in the semester. We did a little hand waving sort of thing saying how it worked, but this is really how this works. And so that's Hooke's law. And so now we have finally learned how to derive it. At the time I said later on we'd get derivation of it. Well, here's the derivation.